Previously you have learned how you can declare a one-dimensional array. For example, like this one, this is an integer array with the size of 5, initialized with 5 values. Okay, so when you do this declaration, what will happen in the memory when you run the program, the computer will randomly select 5 consecutive memory locations to be used for that particular array. Okay, so and it will, this particular location will have a name array, and also the index is 0 starting from this location, 1 2 3 4. Okay, and the values will be put as 3 6 2 5 9. Okay, so let's make it clearer here. So for example, okay, so this is the array that you have declared here and will be created in the memory location here. Okay, so if you declare a two-dimensional array, what you need to do is, like for example here, you say this is the data, this is 3, this is two-dimensional array. Okay, so and what happens is when you declare this two-dimensional array, it will create, it's sort of like create like 3 by 3 location like this. But in terms of visualization, so this is how it's going to create. But in the memory, they say this is the location, so you're going to have a location, this is row 0, row 1, row 2, and this one will be row column 1, column 0, column 1, column 2. Okay, in this location 0 0, this is location 0 1, this is location 0 2. Okay, and so on. But in actual, in the memory, it's not going to be displayed like this. It's going to be displayed, it's not going to be created like this. It will find, since there are 9 locations, it will find 9 consecutive locations where the location for 1 2 3 4 5 6 7 8 9, so you will going to have, so the data is here, so this is data, this is position 0 1, this is 0, this is 0 0. Okay, this is 0, index 0 1, index 0 2, and then it goes to the next row, which is 1 0 1 1, then 1 2, and then it goes to the last row, which is 2 0 2 1 2 2. So this is what is being declared in the memory location. But for simplicity, when we want to learn array, two-dimensional array, we just imagine it as like this. But in actual, in the memory location, it is stored as this. Okay, let's say we initialize this array to be, how you're going to initialize two-dimensional array is by for this one-dimensional array, this is two-dimensional array, how you're going to initialize it is you need to put parentheses here, curly braces here. So because you have 3 columns, no, 3 rows, these column, because you have 3 rows, you need to put like 3, another 3 more curly braces to indicate this is for that one particular row. Okay, and for each particular row you have column, so this column number 1, column number 2, column number 3. So this is the second row, column number 1, column number 2, column number 3 for the second row. This is column number 3, row number 3, column 1, okay, column 2 and column 3. So with this initialization, okay, what will happen is that in the memory is going to store it as like this. Okay, it's going to store it as 4 7 9 2 1 8 2 1 4 9 4 3. Okay, so this is how it is being stored in the memory location. But for visualization, this is how it looks like. Okay, so 2 1 4. Okay, so this is 9 4 3. Okay, so this is just for visualization purpose. Okay, so this is how when you initialize the array, the two-dimensional array, and how it looks like in the memory. Let's say you remove some of the location, some of the initialization, okay, and you, for the last row you only have one data, the second last you only have two data, and this one you have all the data initialized. Okay, so for example, like this one, what will happen is that same like the one-dimensional array, if you did not initialize it, if you did not provide the all the data for all the size of the array, then it will, the remaining one will be defaulted to 0. So for example, in this one, the last row will be defaulted to 0 0 for the two columns. Okay, and this one, okay, it will just simply put this as 0. Okay, so that is how you, if the initialization is not complete, then it will default the remaining one with 0.